In the last video, we have learned how to design a circuit from a schematic to a PCB layout. And I have also asked if this board is properly built. Today, we will employ some features in circuit design to modify the PCB and make it work properly. If you look at the board closely, you will see that the tracks only appear on the top layer, but not both layers of the board as we defined at the beginning. And when we design a compact circuit board, we should try to put the ground away from the power and signal tracks to reduce interference and noise. Thus, we should put the ground track on a separate layer of the PCB. In our case here, we can put it on the bottom layer. To do so, we first group all the pads and track segments associated with the ground. Create a name for the group. Then, pick the grouped item and right-click the mouse button on the track to select Change Layer. The grouped item is now moved to the bottom layer. You can see the tracks associated with the power and signal are on the top layer, and the tracks associated with the ground is on the bottom layer. Next, we want to verify if all the tracks on the PCB have the required width to carry the current we specified earlier. We should use a track width of 0.3 mm for our circuit. The PCB layout is almost done here, except that the component labels are not aligned properly on the silkscreen. So we want to first move the LED label and align it properly, so it doesn't overlap with the other labels. But we can't do so at the moment, because the group feature we used before prevents the LED label from moving independently. Therefore, we need to ungroup this grouped item first. Now we can move each label independently. You can also change the names of the labels according to your needs. When dealing with applications that require electromagnetic shielding or heat dissipation for components such as power transistors, it is useful to include an additional copper surface on the PCB called copper pore. Copper pore is a conductive surface which, when connected to the ground, it can provide additional shielding. And when connected to the thermal pad of a component that generates heat as a byproduct, it can help to dissipate heat. Therefore, copper pore is very useful in many PCB applications. To create a copper pore, we first have to outline the area where we want to place it on the board. We will create a copper pore here for the purpose of shielding. So, we use the Change Layer feature to assign the copper pore to the bottom ground layer. Then, we use the Pour Copper feature to complete the copper pour process. When it is done properly, the copper pour should be connected to the ground on the bottom layer. For a simple circuit like this, we can use the Auto Route Nets feature we mentioned in our last video to carry out the track routing. What if our circuit is more complex, or if it involves more layers? Can it still handle the job? The answer is, not always. If routing cannot be done automatically, we will have to do it manually. We can use the Add Track feature to manually add tracks to the PCB. And if we need to route a track from the top to the bottom layer, or vice versa, we will need to use a feature called Add Via. Via is a conductive pathway that bridges two or more layers on the PCB so to allow a track to go from one layer to another to complete the circuit. A compact PCB with a complex circuitry normally consists of many vias. The disadvantage of via, however, is the additional resistance and the extra manufacturing cost to the PCB. Therefore, we will try to minimize the use of it as much as we can. Sometimes when we design a circuit, we may not be able to find the component schematic or footprint that we need from DesignSpark's default libraries. The Arduino Micro here is one of them. In this case, we can search for schematics and footprints from other third-party resources. Simply click the DesignSpark button at the top. It will bring up the DesignSpark webpage. Create and log in account for yourself before proceeding. Now, go to the menu on top. Then, select PCB Part Library under Resources. It will bring you to the Library Loader download page. Download and install the library loader. When the installation is done, go to your desktop and launch the library loader. Select Search for Parts, and it will bring you to DesignSpark's electronic component search engine. Here, you can enter the name of the component you want to search for, say, the Arduino Micro. Now, look for the particular type of Arduino Micro you want from the list. Click the Build or Request button once you have identified the item you are looking for. Next, look for the particular package type associated with your item. There are many types of component packages you can choose from: through hole, socket type, surface mount, etc. Pick the one that is the most appropriate for your item. In our case, we will go with the dual inline sockets. Now go to the Launch Wizard. Here, we can input all sorts of information about the component, such as physical dimensions and pin configurations, which are necessary when creating the schematic and footprint of the component. After you have finished editing all the information here, you can click the final check button at the bottom to verify the correctness of the information entered. You can proceed to save the part when the green check mark appears. Otherwise, you will have to go back and modify the information. Now, you are all set to download the Arduino Micro. Since I have previously created this same component, a message box now pops up and asks me if I want to overwrite this component. In your case, this will not apply to you. After the files associated with the Arduino Micro are downloaded to your drive, you can move these files to the working directory of your project. Once you go back to the DesignSpark workspace, it will automatically add the schematic to your schematic file. Let's have a look at how this Arduino board appears on a PCB. Simply use the Translate to PCB feature to convert the schematic to a PCB layout, and apply all the required features we have mentioned before. Now, you should have all the basic skills needed to create a schematic and PCB layout for your own application.